Welcome to HP Tuner's GM Gen 5 Training Part 23. In this training module, we're going to be doing an introduction into the torque control system on our Gen 5 vehicles. Without further wait, let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at working with our torque modeling in our GM Gen 5 applications. Now this is a relatively complex subject. I'm going to go and do an overview in here in this tutorial, making sure you understand how the Gen 5 torque model works, the flow of logic that we have going on behind the scenes, and then we'll move in future training modules, taking a look at working with something like our virtual torque. We have a virtual torque tables that we can use to program and correct things such as idle control, or part throttle drivability, or transmission shifting. There's a lot of different pieces of the puzzle, so to speak, for this torque model, so we need to make sure we understand this flow of logic so things make sense later on when we're doing other calibration tasks, such as virtual volumetric efficiency tuning, known as our speed density operation, or the virtual torque tuning. So let's jump in here. Let's take a look at a Gen 5 calibration file. I have my 2018 Yukon Denali file open here. Any Gen 5 file will work to follow along for this tutorial. First thing I want to do is just talk about what we have going on here in terms of the torque model. How does this actually work? This is the very most fundamentals of a torque model. Now, at any given time, we're able to measure what the amount of airflow coming into the engine is going to be. We can use the mass airflow sensor for that. We also have what's known as a speed density operation, where we have a map pressure sensor, and we're going to be using other factors that we can calculate. So it's an estimation or a calculation of the air mass coming into the engine. At any given time, we compare the mass airflow to the speed density, and we come up with a term called dynamic airflow. That's what's actually used for the air mass representation for the engine control module to drive the fueling calculations, even spark timing calculations, variable cam control calculations. Everything hinges upon the dynamic air being correct, so everything else can be calculated from that. Now, knowing the dynamic airflow, we would know what the airflow, air mass is coming in at any given time, and everything's calibrated right with the mass airflow and speed density, it will be accurate. Now, knowing the air mass, we're going to find that if we move more air into the engine or less air into the engine, that's going to make more or less engine torque. That makes sense. So torque is a function of air mass or airflow. Now, what we're going to find is that just because we have a certain amount of air mass coming into the engine, if we don't give it the proper fuel or the proper spark or even the proper variable cam, so the variable cam movement, we'll find that the engine's torque output can greatly suffer. So just because we're moving the air into the engine doesn't mean we're going to have good combustion and that we're going to actually have a good torque output. That all hinges upon a whole bunch of things riding around what's known as maximum brake torque. So the three different variables that can affect our maximum brake torque that we have control over are fuel, spark, and variable cam. Let's take a look here first at spark timing and how this is going to fit into the picture here. So let's just say we have X amount of air mass coming into the engine, doesn't matter what the number is. That amount of air mass needs to be figured out and how it relates to torque. We figure out what that relevance is going to be, airflow to torque, based on the spark timing first, then our EQ ratio, and then our variable cam. So the first graphical illustration I have coming up here is going to try to explain a little bit better here what I'm referencing when I'm talking about maximum brake torque relevant to the torque production of the engine, and then what we're looking at in terms of the actual spark timing, how we can figure out how far away we're from maximum brake torque. Because in theory, maximum brake torque is the peak torque output for the engine, whatever that spark timing is going to be. GM has modeling. We actually have a maximum brake torque timing table. We've talked about that in our spark timing tutorials. That is the reference point that it's going to compare what we have in terms of actual spark timing. So looking at our graphical illustration here, we have our spark timing table, and then we have our corrections. So the base spark timing table plus any corrections that are going on. Corrections are based on EQ ratio, they're based on humidity, intake air temperature, engine coolant temperature, even variable cam position. We'll find whatever the combination is going to be, it'll give us the actual timing, or the timing that we go and deliver to the spark plug, deliver to the coil to fire off the spark plug to initiate our combustion process. So that's our actual timing. Now the actual timing is going to be what we find here. If we take a look at our little graphical plot, I'm going to have this yellow curve, and this represents our torque output relevant to the spark timing that we're going to command. So let's just say here, actual spark timing, let's say it was 20 degrees of timing. That's my red mark. we can see that the curve, I would be moving. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.